Lesson: AI-driven incident response mechanisms. AI-driven incident response mechanisms have become a cornerstone of modern cybersecurity operations, offering a proactive and efficient approach to managing and mitigating security incidents. The integration of AI technologies into incident response processes enhances the capability to detect, analyze, and respond to threats with unprecedented speed and accuracy. This lesson focuses on the actionable insights, practical tools, frameworks, and step-by-step applications that professionals can directly implement to enhance their proficiency in AI-driven incident response. One of the primary advantages of AI in incident response is its ability to process vast amounts of data at speeds unattainable by human analysts. Machine learning algorithms can sift through network logs, user behaviors, and threat intelligence feeds to identify patterns indicative of malicious activity. For instance, AI can be programmed to learn what normal traffic looks like on a network and flag anomalies that could signify a potential breach. According to a study by Ponemon Institute, organizations using AI in their security operations centers reduce the time to identify and contain a breach by as much as 27% compared to those without AI capabilities. A practical tool that exemplifies AI-driven incident response is IBM's QRadar security intelligence platform. This tool employs AI to analyze security data in real time, providing insights into potential threats and automating responses to detected incidents. QRadar integrates machine learning models that continuously improve their threat detection capabilities based on new data inputs. This process includes correlating disparate data sources, such as user activity logs and network traffic, to identify threats that might otherwise go unnoticed. The platform's ability to prioritize alerts based on risk scores allows security teams to focus their efforts on the most critical threats, thereby optimizing resource allocation. Another effective framework for implementing AI in incident response is the MITRE ATT&CK framework. This knowledge base of adversary tactics and techniques is used to develop detection and response strategies. AI algorithms can be trained on the ATT&CK framework to recognize specific threat activities, enabling security teams to automate the identification of attack patterns across their environments. By mapping detected activities to the framework, organizations can understand the potential scope of an attack and prioritize defensive measures. A case study involving a financial institution demonstrated how the integration of AI with the MITRE ATT&CK framework reduced false positive alerts by 80%, allowing the security team to focus on genuine threats. For a step-by-step approach to implementing AI-driven incident response, organizations can follow these key steps. 1. Data collection and integration. Gather and integrate data from various sources, including network logs, endpoint data, and threat intelligence feeds, to create a comprehensive dataset for analysis. Tools like Splunk and Logarithm can facilitate this integration, providing a centralized platform for data aggregation. 2. Model training and deployment. Utilize machine learning models to classify and predict potential security incidents. This involves training models on historical data to recognize patterns of legitimate versus malicious activity. Google's TensorFlow and Microsoft's Azure Machine Learning offer robust platforms for developing and deploying these models. 3. Real-time monitoring and detection. Implement real-time monitoring systems to detect anomalies and potential threats as they occur. AI-driven systems can automatically flag suspicious activities and initiate predefined response protocols. CrowdStrike's Falcon platform leverages AI for endpoint detection and response, providing real-time threat intelligence and automated response capabilities. 4. Automated response and remediation. Develop automated response strategies to contain and remediate identified threats. AI-driven systems can execute predefined actions, such as isolating affected systems or blocking malicious IP addresses without human intervention. The use of playbooks within security orchestration, automation, and response platforms like Palo Alto Networks' Cortex XOR can facilitate this automation. 5. Continuous learning and improvement. Continuously update and refine AI models based on new threat intelligence and incident data. This iterative process ensures that the AI system remains effective against evolving threats. Organizations can leverage feedback loops and reinforcement learning techniques to enhance the system's accuracy and adaptability. AI-driven incident response mechanisms also benefit from collaboration and information sharing within the cybersecurity community. Platforms such as Anomalies Threat Stream enable organizations to share threat intelligence and collaborate on emerging threats, enhancing the collective defense capabilities of participating entities. By integrating shared intelligence into their AI models, organizations can improve their ability to detect and respond to new attack vectors. Despite the advantages, implementing AI-driven incident response comes with challenges. One notable concern is the potential for AI systems to generate false positives or negatives, which can lead to either unnecessary alarm or missed threats. To mitigate this, organizations should regularly validate and fine-tune their AI models, ensuring they are trained on diverse and representative datasets. Additionally, the ethical considerations of deploying AI in cybersecurity operations, such as data privacy and algorithmic bias, must be addressed to maintain trust and compliance. The future of AI-driven incident response is promising, with advancements in machine learning and artificial intelligence poised to further enhance the effectiveness of cybersecurity operations. As AI technologies evolve, they will offer even more sophisticated techniques for threat detection, prediction, and response, empowering organizations to stay ahead of adversaries. In conclusion, AI-driven incident response mechanisms provide a powerful toolset for modern cybersecurity operations. By leveraging AI technologies, organizations can automate and optimize their response to security incidents, improving detection accuracy and reducing response times. Practical tools like IBM's QRadar, frameworks such as MITRE ATT&CK, and step-by-step implementation strategies offer actionable insights for professionals seeking to enhance their incident response capabilities. As the cybersecurity landscape continues to evolve, the integration of AI into incident response processes will be crucial for maintaining robust security postures and effectively mitigating emerging threats.